We're going to take a little time now and just go over these ideas and try to find out, given these measurements, we'll assume they're all in grams. So given these measurements, how many digits of precision or significant digits have been recorded in each particular measurement? This first one should be pretty easy for you to see. There's four, right? There's four numbers written down, so there's four measurements. There's four significant digits in this particular number. This one might be a little tricky, and where these determining a number of significant digits gets tricky is with zeros. They often are sometimes just placeholders. But in this particular case, this zero out in front is actually a placeholder. We like to say leading zeros, so it's leading, it's out here in the front, are not significant. So this particular measurement has three significant digits. This number here, trailing zeros, they're at the end of the number, they're ambiguous. They require some interpretation. And you might remember, for example, that if this measurement is known all the way down to this digit here, that's our first digit that we're not sure about. We know this number to plus or minus 1. And if that was the case, this would have 1, 2, 3, 4, 5 significant digits. It might be the case, however, that we know this number to the nearest tenth. And in that case, we'd say this number has 1, 2, 3, 4 significant digits. Or we may only know it to the nearest hundred. And in that case, this particular number has 3 significant digits. And so it's important to know with trailing zeros what the level of precision of the measurement is. And in order to make this so it's not ambiguous, it's recommended that if you have a number like this, that you write it in scientific notation. So for example, if I wrote this number in scientific notation like this, 1, 2, 3, 4, this would convey to the reader that there were 3 significant digits in the measurement. If, however, I wrote the number like this, I'm telling people, look, I have taken the time to actually write this 0 in. Because I've done that, I'm telling you that this is a decent measurement. It's my first uncertain one, but nevertheless, this is a measurement that we need to take seriously. And so this particular way of writing this number would convey to the reader 4 significant digits. How would we write this number with 5 significant digits? Well, we'd write it like this. I hope you see this. 9.1600 times 10 to the 4th. So the numbers out in front of the times 10 to the whatever, this tells you the number of significant digits in the measurement. So I want to make sure to emphasize here that all of these are the same number written in a different way. They're all 91,600, every single one of them. In this case, all that you're doing by writing it in this way is you're telling people all those digits are measured. In this case, you're telling people that, we only were able to measure this good to the nearest 10. If I write it this way, I'm telling people this measurement is only good to the nearest 100. I don't know what's going on out here. And if you write it this way, we don't really know what's going on in terms of how many of these digits represent measurements. Okay, in this particular number, we're going to count the number of significant digits, and I see some leading zeros that are never significant, so we don't count those. I also see what we call some sandwiched zeros. Sandwiched zeros are behind a leading non-zero digit and an ending non-zero digit. These sandwiched zeros, they're always significant. Of course, if I know the number all the way out here, then I know this one and I know this one as well. So this number would have 1, 2, 3, 4 significant digits. So let's recognize that even this particular zero here is not significant. Let me show you why. If we were to write this number in scientific notation, what would it look like? Well, it would look like this. 3.005 2 times 10 to the negative 2. These are both the same number, just written this one in scientific notation. And usually if you want to figure out, you're a little confused, write the number in scientific notation and then just count the number of digits that you had before the times 10 to the power whatever. Here we see, that dropped, didn't it, when I wrote it in scientific notation. And so writing things in scientific notation, at least with leading zeros, it helps you to see that those don't count. So this particular number and this particular number would be written with 4 significant digits. It's representing measurements in all of these places. This number here, leading zeros are never significant. These trailing zeros, now notice, when I wrote this down, I made a point to write this 0. I also made a point to write this 0. I could have easily written this number like this. I could have also written it like this. But in this case, it's fairly, I hope it's easy for you to see that because I took the time to write these 2 digits down, and I didn't have to, that these represent measurements. And so this number written this way is conveying 3 significant digits. I know this number all the way out to the nearest, what's that, 10th, 100th, 1000th, 10,000th, 100,000th. I'm saying I know this number all the way out to there. If I write the number this way, I'm saying I only know this measurement out to the nearest 1000th, 10th, 100th, 1000th. And here I'm telling people I know this measurement all the way out to the nearest 10,000th place. So this number would have 3 significant digits. This number would have 1 significant digit. And this number would have 2 significant digits. In each case, they all represent the same number, but they represent measurements of different precision. This is a much more precise measurement than this one.